question, Olivia. They want to know if generic chocolate chip cookies have as many chocolate chips as the name brand chocolate chip cookies on average. Because they have lots of time on their hands. They're like, what are we going to do today? Count chocolate chips and chocolate chip cookies. So they randomly selected 10 bags of Chips Ahoy cookies and 10 bags of Great Value and Walmart cookies. I know, I'm really surprised there are not any, there's not trademark infringement right now going on. But, meh. It's free advertising, so there's that too. They selected one cookie from each bag, so 10 cookies total, right? Then they, per bag, I should say, per bag. They carefully broke apart each cookie and counted the number of chocolate chips in each. Here are our results. We're going to need to construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chip cookies and Chips Ahoy cookies. Okay, so there are the number of chips. We want to find the mean number of chocolate chips in Chips Ahoy and Great Value cookies. You don't think they can fit 21 chips in a cookie?
There's 26.
Yeah, that's a lot. That does seem like a lot of chips. No, I think there's cookies in front of my box of cookies. I really enjoy, though, my cookies to be, my chocolate chip cookies should be more chocolate chip.
They should be soft.
Should be soft or hard?
Chips Ahoy, they get more soft.
I prefer homemade cookies over anything else, right? And my homemade cookies should be crispy on the outside and soft on the inside, right? Like bendy, like, you know what I mean? Like not, yeah. But with a crisp bottom. I enjoy it. All right, here we go. So, let's go through this process. First of all, I think I want to just put this stuff in the calculator immediately. Alright, so we're going to enter this stuff in the calculator, and then we'll go ahead and go through, once we have that data in front of us, we'll go through. But, because we have a couple lists, we're going to have to go with a Lesson spreadsheet, right? And we'll call this one, Chips Ahoy. Come on. And I have those numbers here. We got Chips Ahoy was 17, 19, 21, 16, 17, 18, 20, 21, 17, 18. I'll put the numbers back up there for you as well. And then we're going to go back up to this one, and we're going to go Great Value. We'll call it GV. We'll go down. Great Value was, ready, 22, 20, 14, 17, 21, 22, 15, 19, 26, and 18. There we go. Got them in there. Okay. Now that we have our data entered, okay, we're going to go to Doc. And we are going to insert a calculator page first. Let's go ahead and let's perform the or do the confidence interval. Perform the test, kind of, not really. All right, so confidence intervals. Boom. We're gonna choose a 2-sample t interval. So in order to do this, we need to use a t distribution. All right. We're going to go ahead and use data. Our list 1 is Chips Ahoy. We go down. List 2 is going to be Great Value. We don't change that frequency stuff. What was the confidence level? It was 99%, wasn't it?
Yeah.
Let me just double check. Yeah, that's good. Pools, no. Singles, okay. Sorry, I think I'm not getting this. There we go. Alright, so there's all our data. We'll come back to this because we're not quite ready to discuss all of this data yet, right? So our interval is right here. Right, there's our lower and our upper for our interval. And we've got everything we need to plug in all of our numbers into our formulas and stuff like that. So we'll put all that stuff down here in a moment. The next thing that we're going to need to do is be able to check our conditions, right? So for neither the sample size of Chips Ahoy nor the sample size of Great Value, neither of those are greater than 30, right? So what we're going to need to do is look at a graph. So let's go ahead and insert some data and statistics. Well, that button is not working very well. Let's see. Okay. All right, and we're going to go ahead with that and give that variable. And now we're going to need to go to our menu. Wow. Sorry. Menu. Plot type. We're going to go for a box plot. We really would like to have side-by-side box plots in order to look at these in the most efficient way. So we're going to hit menu. We're going to go plot properties. And I believe that we can Okay, sorry, it's been a while since I've done it either, so I was going from memory. So I hit menu. First of all, I changed the plot type to a box plot, right? After you've done that, you're going to go to plot properties. and you're going to add an x variable. That x variable you're going to add is going to be the great value. And when you hit that, you get a second box plot. You're going to have to draw both of those, or draw the distribution of both. But this is the best way to do it all at once, right? You can draw side-by-side box plots, and then you've taken care of making a graphical representation of the data. It looks approximately normal. I don't see any outliers, too much skewness. As a matter of fact, the great value ones look very, very symmetric. So, there we go. So, we've laid some groundwork. Now let's start to do the busy work aspect of this. All right. Well, that's the answer A. So what are we interested in? Our parameter. What is our parameter? It is the difference in mean number of chocolate chips. We'll call that mu sub Chips Ahoy minus, because I believe we put Chips Ahoy first. Great value. That's our parameter of interest. We have no hypothesis, right? So we're not going to do that. We do need to check our assumptions. So unfortunately, n sub Chips Ahoy is equal to 10, which is not greater than 30. So that's not good. It makes us have to do an extra step. And great value is doing the same thing, right? So that means that we need to check. And how we're going to do that? We're going to make a box plot. All right. 13, 27. Look at these. We'll start with great value. We're going to need to label that as well. Alright, so we're at 14, 17, 19-ish, 22, 14, 17. And I did not look at the last value. 26. Alright, so those are all the spots that I need. So I'm going to go ahead and go, boom. There's quartile 1. Boom. Median. Quartile 3. And then all the way up to max. Alright, and this is great value. Alright. Let's go ahead and make our box plot for our Chips Ahoy. Chips Ahoy is going to be 16, 18, 20, 21, 16, 18, 20. I think I'm missing a value. 2021. And this is Hawaii. There we go. So now that we have put these graphs there, we can say there does not appear to be any skewness. Or outliers in the sample distributions of CA and GB. So we will construct a two sample T interval. All right. Now that we've constructed our interval, now that we've met all of our conditions, and we have named our test, let's go ahead and get a test statistic. Okay, our formula is going to be I need a little more space, so there we go. Whether you use a t interval or a z interval, if you have the standard deviation of the entire population, you would use a z interval. In this case, we are only going to have the standard deviations of our sample, so we'll have to use t. All right. So I'm going to go x bar sub CA minus x bar sub GB plus or minus our t star value divided by the standard deviation SGS sub x sub. I want to see if there's a shorter way to write that. We're just going to say s sub 1 over n plus s sub 2 over n. There we go. So that's going to be our formula. It should be 1 and a 2. Sorry. Okay. Let's put the numbers in there. Those numbers are on our calculator, right there. There. So x bar difference is -1. That's going to go right here. Our t star critical value. If we look on our table, is it going to give it to us? I don't believe it's going to give us our critical value. We're going to have to look on our table for our critical value. Yeah. That is going to be 3.25. We need to find the standard deviation of each. 1.77, 1.78, and 3.6. 3.813. So that leads to an interval.
That way I can get quite a little bit of my car. I'll love that.
So negative 4.814 and 2.813.
That was out of the blue. Like I was on my phone, my mom was right next to me too, so I was like, I clicked off the screen, I was like, what's that freaking away?
So there's our interval.
Not for you, son.
Don't read it.
And let's go back and see what this problem was asking us for. We did it. We constructed an interval. Oh, and interval. All right. So. Well, 0 is inside of this interval, right? So we are 99%. Got me all excited. Dude, Lesson 10 captures the.
I don't want to play TV. I want to get rid of it. I want it. I want
All right. B. 0 is contained in the interval. Which is convincing evidence. That there is not a difference. Sorry. I was close to the mean number.